Now let me turn things over to our presenter. Colm, the floor is yours.
Great, thank you, Dylan. Hello, everybody. Today we're going to explore the ideas of value creation, smart system partitioning, and rapid development of IoT systems. Now, during this talk today, I will discuss the following topics. I'm going to start by reviewing the basic concept of the IoT multiplier effect and value creation. I will talk about value loops as a means to enable this value creation and discuss how information transformation happens in IoT systems. I will discuss what smart means in the context of IoT. I will give some examples of smart partitioning that we have created at Analog Devices here today. I will also talk about how we enable customers to rapidly develop IoT systems, and then summarize at the end. So let me start with the IoT enabling effect and value creation. Okay. There are many estimates about the overall economic impact of IoT in the coming years. This one from McKinsey claims that the total economic impact will be $2.7 trillion by 2020. This impact will be realized by improving outcomes, particularly in the areas of healthcare and manufacturing, but also impacting smart agriculture, automotive, and smart city applications as well. And really, the change that we're looking at here is sort of a switch in the way outcomes are realized, right? Basically, we're moving more now from a reactive world today where we only respond when there are problems to being a lot more proactive and more prescriptive, detecting the onset of potential issues earlier and being able to react before they become a major problem. So this enabling effect is going to be realized by substantial investments in IoT infrastructure technologies such as semiconductor systems and services. The result of all of this investment and deployment of IoT systems across many sectors of our economy will be increased life expectancy and improved healthcare outcomes and reduced costs, reduced cost of healthcare delivery and quality and improvement in quality of life, increased manufacturing and supply chain efficiencies, improved food security and sustainability, improved transportation efficiencies, and then improved automotive safety and fuel efficiency, and many, many others. This IoT enabling effect refers to the ratio between the outcomes of the investment and the investment being made. These potential outcomes are what are driving IoT developments and deployments. And this enabling effect represents a potentially huge amount of value creation throughout our economy. So how will this enabling effect be realized? So ultimately, it comes down to changing the behavior in the system of interest. This requires information that is specific and actionable so as to know when and how to modify a behavior. The overall solution value comes from being able to modify behaviors to affect the desired outcome. This requires a feedback loop to monitor and ultimately change the system behavior. Here's an example of from a set of papers a year or two ago from Deloitte and Touche that kind of shows an example of a value loop here. So there are several steps around this loop. First of all, if we start at the top with an action in the real world, right? We use sensors to create and generate information about the physical state of the real world. We communicate this information across many networks from one place to another. During the aggregation phase, we're gathering together information that is taken at different times and also from different sources. Continuing around the loop, we analyze this information to discern patterns or relationships that lead to descriptions, predictions, or even prescriptions for action. And then finally, back at the start again, we act by initiating, maintaining, or changing a physical state or event in the system in response to the analysis. So this looks like a loop, right? And really, before any behavior can be modified, we really need to analyze what's going on in the system so we can decide what's most appropriate. And this value or information loop allows the system to be analyzed so that the most appropriate action can be taken. So as we think about this journey around the loop, right? This tool, the DIKW pyramid, is a very useful tool in thinking about this process, right? DIKW stands for data, information, knowledge, and wisdom, and there are many variations of this concept. I insert here, in this case, understanding as well as an additional step in here, right? As one moves around the loop or up the pyramid, large volumes of data are transformed into progressively more meaningful insights through a series of steps. Data is transformed into information providing answers to the who, what, where, when questions about a system. Knowledge is derived from patterns, addressing the question of how a system behaves. Understanding is derived from learning about the underlying processes in a system, addressing the question of why systems behave in certain ways. And wisdom is derived from applying understanding to learn about the principles governing the behavior of a system. Moving up the pyramid yields insights that are progressively more important and more valuable to customers and end users. They offer progressively more clarity of what actions or behavior change must happen to improve the overall system outcomes.